So like when I go to the doctor, they take my blood pressure and my body mass index and my cholesterol and my blood sugar levels and all that kind of thing. And I thought, if we try to figure out, and nobody had done this, but I thought to myself, if we try to figure out what those indicators would be, what would they be and what would they say? And how does this all work toward the health and future of the ocean? And I was stunned by what I found. I just had no idea. I was just an ignorant person. I'm shameful about it now, but I just actually had no idea how the system worked. And it wasn't until far into my research that I realized that the ocean actually contains what is known as the switch of life. Indeed, life did come from the ocean. And indeed, if life in the ocean were to die, we would die. So as one scientist put it to me, if everything on land were to die tomorrow, everything in the ocean would be fine. But if everything in the ocean were to die tomorrow, everything on land would die as well. We are fully dependent on the systems, the biochemical systems of the ocean for our own survival. So the ocean controls much of the carbon system, it controls much of the climate, it controls the oxygen system, or part of it. Every second breath of air you breathe comes from plankton in the ocean. It's not the big boreal forest, it's not the Amazonian forest, it's from plankton, the plants in the ocean that created the first life on the planet. So as goes the ocean, so go we. So I started to think about this and I thought, well, so what is happening to the ocean? What are the vital signs? In addition, the other thing I didn't get was that when we look around at our land, at what we see is actually only 1% of the living space on the planet. Things that live in air like we do make up only 1% of the living space, or that habitat is only 1%. 99% is in the global ocean, because the global ocean is incredibly deep, and it's all filled with life, it's packed with life, absolutely packed. And I hadn't had that perception. I had realized I was going around writing about the planet's life support systems with a 1% view of the world. So I started to go deep, I started to look really deep, very deep into the ocean. And the thing that stunned me was to discover how little had been really put together. Some of this research is incredibly new. What I do when I do research, because it's just my method, is that I go around and talk to scientists, and scientists tend to be incredibly generous. They take you on field trips with them. I spent a tremendous amount of 2.5 years on research boats around the world, and with scientists looking at what they were doing and trying to put together the pieces of all of this stuff. And the one that is the big one, the one that is sort of going to be the one that you're going to have to know about if you are ever going to be talking fluently about what's happening with the ocean, is something called ocean acidification. How many here have heard of this term, apart from in the intro? You do. So there is a fluency with it. You're an unusual audience, I guess, because you're at this university, but in general terms, when I go and talk about this, as I've done around the world for the last year and a half, few people know what it is, and few people know what causes it. And in fact, until 1999, it was not a known scientific concept, really, in any published way. So the very first paper, the big one in Science, came out in 1999. And this was a paper, I went to talk with a couple of the research scientists who put together this paper. And literally, one of them is Joni Kleypas, who's this terrific scientist who works for the American government in the state, well, in Colorado, of all places. And she works on ocean climate chemistry. So she told me that she and a bunch of other scientists were at a big conference, a biological conference, and they sort of pooled their information and on backs of envelopes, literally on the backs of envelopes at this big conference, and realized that what they were looking at was this enormous process of ocean acidification happening. And she said the implications of this were so immense that she actually went to the bathroom outside the conference room and threw up. Because until then, she hadn't realized, and many scientists had not realized, that the ocean was mutable. They thought that it was the big buffer that protected the air and the atmosphere. You can still hear this discourse in scientists and among politicians. They say, oh, well, aren't we lucky we have the ocean to absorb all that carbon dioxide, to absorb all that heat? It's saving us from worse climate change. That may be true. It may be soaking up some of the CO2. But what's happening with that is that it's altering the chemistry of the global ocean. And that's the big issue that people aren't talking about. So, and when they put out this paper in 1999, it was incredibly controversial. It was so controversial, in fact, that they had to put out a follow-up article almost immediately describing in detail the actual technicality of the chemistry that happens. And so in a nutshell, what happens is that as we burn fossil fuels, we call them fossil fuels, what they are the body's of plants and animals that lived millions and millions of years ago that have been stored in the body of the earth. We dig them up and we burn them for fuel and for other things. And the carbon that has been stored in their bodies and stored in the body of the planet goes into the atmosphere in the form of CO2. This is roughly what goes on. So about a third of that ancient CO2, that ancient carbon that's in the air in the form of carbon dioxide gas, about a third of that gets absorbed into the global ocean. A third of it stays in the atmosphere, a third of it goes back onto the earth, the land part of the earth. So as it goes into the global ocean, it creates a mild, in the air, we know what it does, it hangs there. It's a greater proportion of the global atmosphere, a greater concentration in the global atmosphere than it was before we started burning all these fuels. But when it goes, and it hangs there, it holds heat against the planet. When it goes into the ocean, which we cannot stop it from doing, by the way, it reacts chemically with water in the ocean. And it creates, excuse me, is there some water I could get?